Welcome, Dominik, to the IoT For All Podcast. Thanks for being here this week.
Yeah, thank you for having me, Ryan.
Yeah, it's great to have you. Very interesting topic we have planned for today. Before we get into it, I would love it if you could just kind of give an introduction about yourself and the company for our audience.
I'm Dominik Obermaier. I'm founder and CTO at a company called HiveMQ. We provide data infrastructures for the largest companies in the world, but also for smaller companies up to startups. So we work with mainly Fortune 500 companies and Fortune 2000 companies for their edge to cloud data platforms. And one of the things that we do a lot these days is around the unified namespace concept and an implementation of this, especially for manufacturing customers in the energy space, but also in the automotive space and also in the logistics space.
You brought up unified namespace. That's kind of what we wanted to talk about today. For our audience's benefit, could you break down what unified namespace is and how does it differ from traditional industrial data architectures that exist?
So let me first start how it differs from the existing industrial data architectures, because it's very simple. Existing industrial data architectures are at the end of the day are silos. And we will cover IT, OT conversions, I think also quite a bit. But let me now break it down. So companies today are asking questions, executives and companies are asking a question like, how can we make use of the data that we have in our factories, in our industries, on our assets? And the amount of data that's locked in companies is absolutely crazy. So just as an example, what Rockwell currently has, and I heard one of their VPs said this also in a podcast episode, Rockwell currently has so many PLCs out there with so much data, they produce the same amount of data 6 times what ChatGPT 3.5 was trained upon per year. And this is only a piece of what you find in data infrastructures. So what's happening is in the age of AI, where data finally gets important enough to get used from edge to cloud, companies find themselves in a situation where all of the data is locked in somewhere in some proprietary ecosystem, and you cannot make use of it for multiple reasons. And what MIT research together with Microsoft found out in a study from June 2024 was that more than 50% of executives that we asked, this was 1,000 executives in companies, more than 50% have the problem that data is not accessible. And more than 50% have the problem that data might be accessible, but it's not usable. And then also more than 50% also have a problem with data governance. So data might be there, but actually there is a governance issue around this. And so overall, the question is now, how can you create a data architecture that helps you unlock the data from edge to cloud and also democratizes the data? Most of our customers, like if I look at the shop floors, if they're in a factory setting, I mean, they have extremely smart people there. And people get hired to solve hard problems, to optimize processes, but they don't have access to data. And this is one of the things that the unified namespace architecture solves. And the unified namespace in itself, it's a concept. It's a concept that, so just imagine you would have all of the operational data together with other contextual data available to all of the stakeholders in real time across the organization, from edge to cloud, from people working in factories to the IT departments and the managers and all the executives who need access for basically aggregate access to all of the data. Asking questions like, how are my factories globally doing? I have more than 200 factories. How are they producing? What's the mean time to repair currently? Do we have downtime, yes or no? And one would assume in 2024, this is a solved problem. I mean, we've built the internet and then we connected all of these things. Why is this still a problem? The reality is with our customers, it is a huge problem. It's the number one problem that all of the VPs responsible for smart manufacturing or digitization currently have. It's the data is not accessible and it's not usable. And with the unified namespace, democratized the data access by an infrastructure that you can access from edge to cloud for all of the stakeholders and get real-time access to it. Imagine it's similar to as if you would have a data warehouse that would be accessible to all of the stakeholders in a distributed way.
If an organization is looking to adopt new data architectures, just in general, how does UNS help overcome those hurdles that they may encounter when doing that?
When it comes to data architectures, first of all, the question is there existing data architectures? For many, there is not. There is silos. There's usually IT departments of data architectures. But in order to bridge the IT OT gap, to converge it, this is usually a bit of a problem. And what we find is that for many organizations, this also has to do with, if you look at the organization, manufacturing and also IT is usually separated up until top management. And now with these data architectures, you're bridging these gaps. And what most companies do today in order to achieve that is making sure they have software that brings the assets that you find on a shop floor, for example, or if you're in energy sector, that are somewhere remote, that you bring these assets into, first of all, a unified infrastructure. And the problem that you have is there is a lot of different languages out there. So also what's happening is usually you have this kind of brownfield environment where you have very, very old technology that still works, that nobody wants to replace, nobody wants to touch, that's 40 years plus old, that has some old technology and proprietary language, and proprietary what's called protocols there. And then you have also newer ones. And I mean, overall, if you sum it up, there is way more than 150 different communication protocols out there, similar to human languages. And what's required in their first step is you need to have this kind of almost like what we call gateway. It's a converter, protocol converter that converts all of the different protocols into something unified. And what the industry now is using for this is a communication protocol called MQTT that's been really popular since 2010. And it's been used for most of the Internet of Things devices out there. And since I would say for more than 5 years now, MQTT is being used heavily in everything for data infrastructures, for connecting OT like assets, but also IT systems. So long story short, you connect everything that's out there into an MQTT namespace, and the MQTT communication protocol and infrastructure allows you to route the data edge to cloud and also makes it accessible edge to cloud.
How is unified namespace transforming how enterprises really think about things like data architecture, right? Industrial IoT data management, data ops, digital transformation. What is that enabling the organizations to do, and how to kind of adjust their thinking with these capabilities?
I think one of the key aspects of it is making the data accessible and like democratize the data. What is called in the industry data democratization. So, and also you have different things that you or different, let's say, machines, humans, and applications that you want to integrate. In a data infrastructure, usually you have at least 3 distinct and unique, let's say, pieces that you want to integrate. This is assets, these are machines, and you want to integrate it either unidirectional, this means you want it to send data into the namespace, but you also might want to consume things from the namespace. Then you want to have applications. This is in the manufacturing context, is very often MES systems. This might also be ERP systems, this might be SCADA systems, or many, many other systems that depending on the industry you might have. And the third thing, and this is what's been neglected a lot in the recent years, is humans. Humans should be able to access the data properly, not only machines. And we now go away from, with the unified namespace concept, the industry has gone away from this what's called point-to-point integrations. In the past, and I think pretty much in 2008, this began there, also new ways of communication with OPC UA in particular emerged in the industry. There was a lot of these point-to-point things where you say, oh, I have an ERP system and I have an MES system that's integrated. I have a specific sensor and I have this other system that's integrated. At the end of the day, you get this nice spaghetti bowl of connections. It's great, it works. But if you ever want to maintain it, if you would change the routing of the data, you get into an issue. It was really interesting. One customer recently told me, was a chief architect at a very large Fortune 500 company who adopted unified namespace. And he said, yeah, what is so interesting, what the PLCs, when they emerged, was to the wiring, to the hard wiring. The unified namespace is to data what the hard wiring was before. So it's really a new way of routing data and make it easier to access. But also you now have, as an example, executives that can interact with the namespace with chatbots, as an example. You can now actually ask answers now with AI technology on the data you have at cloud.
Something you mentioned earlier I wanted to kind of come back to is the IT/OT convergence, which is obviously a very popular topic in industrial IoT, Industry 4.0 use cases. So, how is UNS different from other data architectures when an organization is implementing IT/OT convergence?
I think the challenge that many of our customers have is there is no really good way of bridging this gap has been identified. So and the unified namespace it really helps unifying the data flow and then also provide the real-time insights and also enabling the legacy systems. One of the things that also is really interesting once we have this kind of data platform that bridges the gap between OT and IT, you will find there's a lot of data. In the beginning, I made the example was Rockwell, what they see how much data is being produced by a single PLC, and large corporations that might have tens or even hundreds of factories across the globe. They have such a diverse set of infrastructure, and then now they have different vendors, and none of these are interoperable. I mean, there is communication standards like OPC that give the illusion that things are interoperable, but the data itself is really not usable. It's not really usable enterprise-wide. And so what you need to do is, first of all, you need to have the transport layer, and then you need to also, on the data layer, make everything usable, contextualize the data, and also make sure you can use it further. And then with the MQTT protocol and the MQTT infrastructure, which is the basis of the unified namespace, then you can actually really physically bridge OT and IT systems by actually moving the data around. And it's really interesting if you look at the scalability, like the amount of data is mind blowing. So what also we found is at some point of time, companies that implement unified namespace, they also need to understand what do I do with all of this data. Traditionally, most say, you know what, let's just pump it into a data lake somewhere. Here we have in the cloud, let's move all of the data from all of the factories into a data lake. The problem is the amount of data there and the amount of unstructured data, even more important, is not really usable in a data lake. And it's really very, very cost inefficient to do it like this. So what you want is to have this edge to cloud infrastructure being able to only move the data to places where you actually want the data. So scalability is something extremely important further down the line that many companies face once they started implementing a UMS. And this is really awesome, this kind of enterprise-grade software that allows you to work.
What should somebody look for in an MQTT platform when implementing UNS?
For the listeners who haven't heard of MQTT, it might be good to have a quick refresh on this. So this is a technology that's it's a message technology for messaging. It was developed for moving data pretty much across the globe over wireless technology like cellular networks, but also over wired connections. And since 2010, it got really, really popular for everything in the Internet of Things. And since a few years, it's being used in data infrastructures, especially in industrial IoT use cases. The MQTT protocol, the question is, why is it so popular? Why is everybody adopting it? And the main reason is extremely simple to implement on the client side. This means if you have an asset, if you have a PLC, and most of the PLC vendors today support MQTT off the box already. If you have anything like this or an application, it's trivial for every software engineer to implement MQTT. The problem now is that it's so simple on the client that the server, the MQTT server that's actually moving the data around, it's very, very hard to build. It's a very tough problem. There's some open source solutions out there that many people start with. The most popular is a software called Mosquito that many listeners might know from their home automation systems. It's really popular there. But there's also enterprise-grade MQTT software like HiveMQ that specializes in a few aspects, especially around enterprise security, especially around the integrations into enterprise environments. So there's a lot of different systems like databases and other systems you need to integrate, but also scalability. So to bring this into perspective, the amount of data you can move through a single system, we have a customer that does 3 to 4 times the traffic of WhatsApp globally or one installation. So it's a mind-blowing amount of data that gets moved every second across the whole enterprise. So if you, and then also the other thing is you need to do this in a reliable and highly available way. And so I would say when many start with open source, usually once you get into enterprise grade, you start with vendors like HiveMQ to actually implement the edge to cloud data infrastructure.
And if we look into the future here a bit, what trends are you seeing kind of in industrial data management, and kind of where does UNS fit into that landscape?
There's multiple trends. I think a really key is what's called data democratization, giving the right people the access to data when they need it. And this could be everything from electricians to data scientists. This is something that's a key driver. This is actually digitization, also making the data available to the right stakeholders at the right time. Another key thing is interoperability. Now in 2024 and then 2025, the days are over where every vendor provides their own data silo. The industry suffers from this now for many, many years. And I think today, in today's world, there is really no need to fall to this trap again that you have this massive data silos. So it's a key trend also. And if you also go, for example, ask analysts at Gartner, they even provide a reference architecture based on unified namespace with MQTT that exactly also addresses these kind of things, especially interoperability. And then there's another thing that's really driving also these initiatives, and this is AI. I can't remember a single customer that does not have any kind of AI project that's strategic. So all of the companies out there are trying to figure out how can they drive down the costs and increase the basically the efficiency, the operational efficiency, also with AI. But now the problem is, in order to make use of AI, you need to have data in a way that's usable for AI. And you actually want to use AI to drive decisions not a week later or 2 weeks later, but in the and this is also another key trend that we see.
One of the last things I want to ask you before we wrap up here is if I'm an organization listening to this, what advice do you have for them wishing to transition from maybe a legacy system to a UNS based architecture?
The key for most organizations is to not disrupt anything that's working. Well, so this is something that most of the VPs I'm working with. This is a key concern. Like, how can you actually bring these new possibilities into an organization without harming anything that's working at the moment? Most companies do not have the luxury to start on a greenfield. They usually have this kind of brownfield environments. And so the advice that we usually give is find a pilot, start there. This is usually for most companies one factory, or two factories at most, and then start bringing in these new technologies besides the already existing one. So this would look like the following. So you would, for example, add an edge gateway into your shop floor, and then just basically have a second data channel and move the data out, and then move it across the organization into some other system. Start there, and from there you increase, and then you show impact, and then you show the value to the organization. No need for major investments, and also no need to disrupt anything that's working.
So, given everything we've talked about, are there any use cases that you are able to kind of share on here? Just kind of maybe talk through, just to maybe put it into context for our audience here before we wrap up.
For the people who want to learn more on the HiveMQ website, we also have a lot of public case studies, also videos where people can dive into the results and also how you implement something like this actually. Let's do a non-manufacturing use case actually, because we talked so much about manufacturing. For the listeners in the UK, you might know this company. It's a company called Anglian Water, and they are the largest geographical water and water recycling company in the UK. And they have implemented a unified namespace. And with industrial IoT technologies, they also really care about digital twins. And they build everything on top also of MQTT and also HiveMQ technology. And it's really interesting. So this is a utility in a remote asset use case. And with very little effort, they got much better insight into the asset performance. Actually, it's the first time they actually see the asset performance and what's happening here. And there's also a way better integration between OT and IT environments, so the systems can actually exchange data in a way that's usable. And this is a very high level of security. So security is extremely important for a company like this. And they could make it happen in a very short amount of time. And the results is they save a lot of money. Like if you're in the wastewater industry, there's a lot of fees and fines actually that you pay if something's not going correctly. And in the water, with this new architecture they've built with a unified namespace, they could achieve that and actually save a lot of money along the way.
Fantastic. Well, thank you for kind of just coming on here and talking about this topic for our audience, breaking it down, kind of explaining, giving advice, all the good stuff that they need to kind of get very familiarized with this topic. You already mentioned the website's a great resource. Any other places you want to send them to learn more, follow up with questions, anything like that?
Yeah, I think the best way to learn about unified namespace is the HiveMQ.com website has a lot of resources around this. But other than this, also Google. If you Google for unified namespace, you will find a lot of examples and what the industry is doing here. Other than this, HiveMQ.com is a great entry point.
Well, Dominic, thank you so much for your time. Really appreciate it. We're excited to get this out to our audience. So if anybody listening out there has any questions, please feel free to check out the website, reach out. If you have any kind of follow-ups or anything you want to learn more about. But thank you for your time, and I'm sure we'll talk again soon.
Awesome. Thank you, Ryan.